Yeah. Hello, this is Jake here, and today I'm with Mike again.
Hello.
And we are going to get the door all working today because Mike has been extra busy, haven't you? He sent me a video of what it should do, and once it's all fitted in this episode, we will show you what it will do.
Hopefully.
That's the plan. You've built a lovely little thing we're going to take a look at in a minute. The door is, we've done this last time where it goes up and down. We will have to do a little bit of work on the side, so the rope and the string and everything with the door, so it looks legit. So yeah, we're going to get this video kicked off and we shall show you what Mike has been busy with.
Busy.
Right,
So here we are. I'm just showing you, the audience, and Jake here, what I've done with this servo. Well, not this one. This one. This is a standard servo. Nothing too fancy. And what I've done is I've modified it to be a standard servo with an arm at the top here to a linear servo with two endpoints. So this will now move all the way across and stop at this micro switch, or all the way back and stop at this micro switch. There's some of the casing and things from it. Now the modification involved from that to that was this little potentiometer, little variable resistor has been removed. It's got the 3 wires on there. That's now been replaced on here by 2 resistors. So you've got your centre wire in the middle, and then your 2 outers. So that's basically been replaced with that. So centre wire at the middle connected between the 2 resistors, and then each resistor into the board. That centralises the servo motor, so if you move forward it'll move forward, and if you pull back it'll move back, but it'll always go back to the centre. Now the modification on this to make it a linear actuator rather than a rotary mechanism is the output for the motor is here and here. That would generally go straight to the motor, but in this case, because we want it to stop at either end, so that basically it would go from the board to the motor, but in this case it goes to the board, through the switch and the diode to the motor, and then same on that side. So you've got switch here with a diode, switch here with a diode, then you have the motor and then the main board. So if I show you now what this does, or does, or all of the above. And then it stops at the end point, and then all the way the other way. And stops at the end point, and it'll keep on doing that when you either flick a switch or move the stick on the radio. Now, for all those people out there that are going, oh, how can I get one of them? How can I make one of them? I don't have a 3D printer, or I don't have this or that. This was purely made out of a servo and plastic card. So, standard plastic card from the model shop, standard servo, a couple of diodes. These I think they're 400, yeah, N400, so nothing too special. 2 micro switches and 2 resistors for the board. I think they're somewhere in the K2, 2.1, 2.2, something like that, K resistors. The shaft itself was just threaded rod, also from the model shop. So this piece here, which is running up and down the shaft, is one of these things. Oh, where are you? Usually found, I've mainly used them on sort of control horns for the wing and things like that. There's a bar that goes through there with a collet, and then that would then connect to the servo. So it's basically one of those that's running up and down there. As for the bearings at both ends, I've used the servo eyelets, little brass things that you can get. They usually fit into there. I've used them as the bearing ends because they're not. It doesn't need anything too fancy in there. It's not moving fast enough. It's not moving long enough. I just put a bit of grease in there and it's perfectly adequate. Right, the gears that I used in this gearbox are the pinion on the motor and the third gear in the gearbox, which is the one that sits up high here. So not the one with the output, the one on the opposite side. That gear was used. The diodes that we use in here are N4003 diodes. Reasonably common. One used for either side of the switch.
Right, Mike's just warming up his gun.
Yep.
Glue gun.
Glue gun.
So our goal is now to actually fit this lovely little device.
Yeah. The reason I'm using a glue gun is if I put just two spots either end, one it'll be strong enough to hold it in there quite happily, and the other reason is if Jake decides he wants to remove it or take it out or whatever, he can cut down the sides and remove it at any time that he needed to. I mean, you could use a selection of glues for that. You could use either contact adhesive or impact adhesive as it's known, hot glue gun, normal sort of airfix type glues, or cynos. So you know, many glues could be used, but in this case we're using hot glue gun.
Right, so Mike has fitted the, what are we calling it?
Linear actuator.
Right.
Which is yeah, glued it in. Bit of hot snot. So if he needs to, he can at some point just cut down the sides and remove it. But that's plenty strong enough to hold that into position. This is where Jake's gonna have it back now because he wants to finish off the rest of the vessel. I've glued the board off to the one side down here out of the way for the moment. Same again, hot snot. It can be removed if needed. But quite firm if it's going to stay there. Jake's going to do now is take it back with him and put on things like the top deck. You can attach a rope to the mechanism through up where it needs to go up to the front door. Right,
we've got it all working. We did just give it a trial run off camera. I am here as well. Here I am. Mike's there. So the door's working, so Mike, do the honours. With a bit of weight, obviously this will go down when the tank and everything. But we still got to put the back on this, so would it be worth putting maybe a coin in now so it just gives it a
little bit of weight in there just to allow it to sort of fall under its own weight a little bit.
And obviously you got to imagine our lovely Sherman tank driving off here.
Yep.
And we got him there.
You got him there. Yep. Yeah.
So put the vamp back up, Mike. Boom.
Cool.
All we got to do, I got to do now, is just fit the attachments here, and then I can put the string off.
That'll guide the wire. That'll guide the string through. So it won't do that clicky thing which you just saw a second ago.
Yeah, so I'll get that all sorted. I'll get that done, ready for the next episode. So yeah, what we're going to do now is just say goodbye and finish the video. Right, we've come to the end of the episode. The landing craft is doing what it should do with the door. We will have to put a little bit of weight just out the door, come all the way down.
It's a bit light at the moment.
Yeah, but easily done. Mike's done a fantastic job with that mechanism. And all I got to do now really...
You can't say linear actuator. So.
You kept making me laugh. So, yeah, basically we'll get that done. The next episode we're going to have a look at getting these motors wired up with some old servos.
Modified servos, yeah.
Yeah, so we don't have to be spending too much money on ESCs and all that.
Yep.
So yeah, I want to thank you all for watching. Please give me a like and subscribe. Thank you all to all new subscribers as well. And I will be putting some links on Facebook to this episode. So if you're watching this from following the link from Facebook, thank you. I hope you enjoy. I hope we're not too much of a pain in the ass for you all. So, yeah, good. So yeah, thank you all for watching. And I shall see you all in the next episode, and Mike will too.
Alright, take care for now.
Bye.